Fellow chemists, welcome back. It's the third installment in our organic reaction series. We've been breaking down alcohol oxidation in the previous episodes, so catch up using the cards below. But today, get ready for something thrilling. We're diving headfirst into the world of esterification. We'll uncover the magic of predicting products, understand the reaction conditions, and unlock the secrets to maximising rate and yield. Hit that subscribe button and let's get started. Esterification is the reaction which gives us esters, and while that might not come as a big surprise, there's a lot more to it than meets the eye. To get started, you need to know two ingredients, an alcohol and a carboxylic acid. These two buddies can combine forces to create the mighty ester molecule, but they're reluctant partners and need the presence of an acid catalyst, typically sulfuric acid. Besides esters, this reaction also generates water as a little byproduct. That's why it falls under the category of condensation reactions. There are a few extra details to pay attention to here. Have you noticed that the arrow between reactants and products goes both ways? This tells us that esterification is reversible. It is also producing energy, which means esterification is exothermic. These details will be important later when we discuss reaction yield. The beauty of esterification lies in its versatility. You can create a wide range of esters using this technique. And as you might already know, esters can have quite distinctive smells, some pleasant and others not so much. For instance, when you're whipping up isomal acetate, get ready for a delightful banana land, wonderful aromas. But if you're working with ethyl isovalerate, well, your lab might end up smelling more like a sweaty sock drawer. Chemistry sure has its surprises. Alright, let's dive into some real-world examples of esterification and get to know the esters that come out of it. Let's kick things off with good old ethanoic acid and mix it up with good old ethanol. All in the presence of our trusty companion, sulfuric acid. A dash of heat, and a bit of time, and magic happens. What you get is ethyl ethanoate, accompanied by water. Now, ethyl ethanoate isn't just any chemical. It's super useful. You'll find it making appearances in various industrial processes, from pharmaceutical manufacture to the decaffeination of your morning coffee. It's a versatile compound that often finds its way into many senior school exam questions, so it's a good idea to get familiar. Here's another intriguing example. Imagine we kick things off with propanoic acid. We introduce our trusty catalyst, sulfuric acid, but here's where it gets interesting. We're using a secondary alcohol, propan-2-ol. The result? An esterification reaction, of course. However, the product is a little, well, crooked. You see, the alcohol having an OH group on the second carbon formed the ester bond. This results in a methyl group in the final product. Voila! We have a compound with the name methyl ethyl propanoate. Here is a word of warning. Don't forget about the water. It's easily overlooked in the excitement of the reaction, but the equation is incomplete without it. Let's take a closer look at how esterification unfolds in the lab. When we're crafting something like ethyl ethanoate, we typically use a round bottom flask. We combine our reactants, acidify them, and place them in a sand bath. Why sand? Well, it offers consistent, controlled heating and can maintain a temperature just below the alcohol's boiling point. This setup has a dual purpose. It keeps things hot for a good reaction rate, while preventing evaporation and loss of the alcohol reactants. We often add a condensation tube to capture any runaway reactant gases and return them to the pot. Esterification reactions are exothermic, meaning very high temperatures favour the reverse reaction and reduce our yield. So this moderate temperature strikes a balance for an acceptable rate and yield. Sulfuric acid is a superstar in this reaction. As mentioned previously, it acts as a catalyst, speeding up the reaction. It also boosts the yield because it is hygroscopic and loves water. As water forms during the reaction, sulfuric acid eagerly absorbs it. This maintains a high concentration of our reactants and shifts the position of equilibrium to favour the ester product. Esterification can be slow. Lab procedures often take hours. During this time, you'll see changes. Alcohols and carboxylic acids, usually water-soluble and colourless, transform into darker, water-insoluble esters, forming a clear layer on top of the reactants. There's a lot going on this lab setup, and it might seem overwhelming. I got you guys. Check out this cheat table. You can use it as a resource to remember the key points. Speaking of resources, have you come across my Teachers Pay Teachers? Introducing Learn with Longman, your ultimate destination for high-quality educational materials. Click on the link in the description to unlock educational ease. Dive into this comprehensive booklet covering everything about organic reactions. Alright, let's dip our toes with this simple chemical reaction question. Your task is to write balanced chemical equations for the reaction between methanol and ethanoic acid. And don't forget to provide the full structural formula for all reactants and products. Also make sure to note down any relevant observations. In an exam setting, this question would typically be worth 4 marks, so allocate yourself 4 minutes and then we'll reveal the answer. Now, let's compare your answer to the marking guide. Did you provide the correct structural formula for all reactants and products? Remember to include water as a product? Include sulfuric acid as a catalyst? Did you use reversible arrows to indicate that this is a reversible reaction? Also, don't forget to describe the observations, including the fruity smell of the ester and the brown immiscible but clear layer which forms. Alright, here's another question for you. Keep in mind that this question is just one part of an extended series, so it's essential to understand the context. It's all about esterification, a process known to be exothermic, and the goal is to identify the conditions which will optimise both the rate and yield of the reaction. Take your time with this one and carefully reflect on what you've learnt through the video. Now let's refer to the marking guide. Did you manage to accomplish the following? Discuss the factors that increase the rate, such as temperature and the addition of catalysts. Consider the elements that affect yield, like lowering the temperature and the hygroscopic nature of sulfuric acid. Questions like these, where you need to provide detailed written responses, can often be a bit challenging for senior school students. However, remember that practice makes perfect, so keep practicing and refining your skills in tackling such questions. As we wrap up this video, I hope you've absorbed more knowledge than sulfuric acid would water during esterification. Don't forget to hit that subscribe button and dive into Learn with Longman for extra brain food. Thanks for tuning in.